Math 13 students. There you are. So I've got a couple of examples here. We're going to take a look at some of the material from section 8.1. Now we're going to start with some of the hypothesis material and how to correctly write a null and alternative hypothesis for a test of hypotheses. So let me jump over to my other screen. We'll get going. All right, so 8.1, writing hypotheses. Now, I'll remind people that we have two. We have the null hypothesis. The null hypothesis is going to be the statement that includes equality. So, if what you are reading is something like a less than or equal to, a greater than or equal to, or an equal to, if that is the case, then we have the null hypothesis. And I'm going to point something out. Regardless of the way the statement is written, we're always going to write the null hypothesis with an equals, regardless of the direct translation. So always there. And then we have the alternative hypothesis, H sub 1. If my statement is written with a less than, a greater than, or a not equal to, or perhaps different from, this is the case, I will have the alternative hypothesis. And you'll note with the alternative hypothesis, there is no equals whatsoever, ever. So we're going to take a look at a couple of examples. We're going to do a couple of different things. We're going to identify the population that is being hypothesized about. We're going to take a look at the claim that is written. We're going to develop the null and the alternative hypothesis, and then we're going to try to identify the tail of the test. So I got a couple of examples here. The first example looks something like this. At least 60% of students will take stats. All right, so that is a claim about students. Students everywhere, here, there, everywhere. So let's go ahead and identify first the population. So we're going to identify the population. I will realize that we're talking about students. So the population, students. Now let's take a look at the claim as it is written. We have the claim that at least 60% of students will take statistics. And the idea is to translate that claim into some sort of mathematical statement. If I translate that claim, it's about a population proportion. P is greater than or equal to 60%. And I'll notice greater than or equal is a statement that includes equality. So what I have here is the claim in this case, because it contains equality, P greater than or equal to 60%, it is destined to be the null hypothesis. Now, we have to deduce from that the alternative. Remember, these are either or types of questions. They can't be true at the same time. So the flip side of greater than or equal to is P less than 60%. And you'll notice that that particular claim does not contain equality. So we can go ahead and write our claim, H naught P equals 60%. And I'll remind people that regardless of how that claim is worded, we always write the null hypothesis with a simple equal sign. The alternative, P is less than 60%. So there we have it. We've got the null and we've got the alternative hypothesis. All right, let's take a look at another example. Oh, I just said we're going to find the tail of the test. I'll notice that this particular test, the alternative hypothesis, this is will set the tail for us, is a less than or equal to. So it points to the left. We have a left tail test. All right, let's take a look at another example. The mean commute time in Salinas is more than 40 minutes. So there's my claim. Now, I'll note that this particular claim is about the mean commute time. So my claim will involve mu. And I note that the mean commute time, the claim is that it is more than 40 minutes. So if I take that information, I can note that the claim looks like mu is greater than 40 minutes. And I will note that within that claim, there is no claim of equality. So I would assume then that this has got to be the alternative hypothesis. Now, the flip side of being greater than a value is to be less than or equal to the value. That is the flip side. And I'll note that this particular statement contains equality. So it's clear that this particular statement must somehow now become the null hypothesis. So if we bring that all back, we've got the null hypothesis, mu equals 40 minutes. And again, regardless of the translation involving equality, the convention is to write that with an equals. The alternative, mu is greater than 40 minutes. So there we have it. This time the inequality points to the far right. This means that in this case, we have a right tail test. So that means if I were to look at this under a distribution picture, the data that I will be interested in, the evidence, is over here on the far right. This value here in the middle is the null hypothesis. Depending on where the data falls, I might stick with the null hypothesis, or I might go with the alternative. I just need to know where that data will fall. That's the sample data and a couple of other things that we'll talk about in further lectures. Thank you for now, and I'll say goodbye, and we'll get back together soon.